Hello and welcome to another lesson with me. Today we are going to solve and find voltages and currents in an electric circuit. Let's take a look. As you see, we are going to find currents and voltages. So here we have two loops. It is I1 and it is I2. Okay, this is I2. And something else, as you see here, we have a node here. We have to put KCL at point A. It is I1 equals to I2 plus I3. Okay, so wait a minute to correct it here. Okay, so and something else, as you see here, when you look at this to imaginary current, as you see, I1 is equal to this I1 with capital I. Okay, I3 and I2 are the same, and I2 is I1 minus it is I1 minus I3. It's better to say. So and instead of I1 you can use I1, and I3 is I2. Okay, so we have these three equations. Oh, wait a minute. Yes, this one, and this one. So let's go and have KVL. KVL 1 is 3 volt equals to V1 plus V2, and V1, as you see, it is 8 ohm, and as you know, this is another equation, V equals RI. So this is another one. So V1 8 ohm and I1, okay, plus V2 is 3, and I2 is I1 minus, okay, I2. On the other hand, so we have another KVL 3 if V1 plus V3, it is 8 I1 plus 6 I2. Okay, so right now let's solve this equation. This part is 3I1 minus 3I2. Okay, I have to go to another page. KVL 1, 3 equals, yes, 8 these two together is 2, and so it is the same. Okay, so right now we have two equations, guys. So equation 1, okay, and equation 2, and we must find I1 and I2. The best way is this. If I multiple I1, okay, the first equation multiple of a multiple of 2. So you can see this one. Let's write it here. If I equal this multiple 2, so you can see, or I was okay, it doesn't matter. So or we can, for example, divide the second equation, divide by 2. But both of them are the same. It's better to do the second part, okay? This is the first equation. The second equation is this. If I divide it to 2, so this is 15. y1 plus 3i2. This is the second one. So right now we have two equations. I will write it here again. So it is very clear if we add them together. So these two, nothing. Here is 45 equals to 15 I1. So it shows that I1 is 45 divided by 15. It is 3 ampere. And based on this, I1 and I1 are the same. So I1, 3 ampere equals to I1. Sorry. This is the first thing. So this is I1. Let's put it, for example, in one equation. If I put this in one equation, for example, it doesn't matter. For example, this one. If I put it there, I will understand that 15 equals to 4 multiplied 3i1 plus 3i2. It is 12. So it shows that 3i2 equals to 15 minus 12 is 3. So I2 equals to 3 divided by 3 is 1 ampere. Okay, but if you look at the this chart, as you see, I2 and I3 are the same. Okay, so it is the same as I3. Let's go to the next page and I write it here that I1, okay, we found this. I1 equal to I1. It is the same as 3 ampere. I2 equals to I3 equals to 1 ampere, as I see. Yes. And look at the KCL again. I2 is I1 minus I2. I1 minus I2. What is I1? 3 ampere minus I2 is 1 ampere equals to 2 ampere. But right now we found I1, I2, and I3. Right now let's go and find V1, V2, and V3. So V1 based on the circuit, V1 is 8 and I1. V2 is 3 I2. And I3 is 6 I3. So 8 ohm, I1, here is 3 ampere, 24 volts. And V2 is 3 I2. I2 is 2 ampere. 3, 2 is 6 volt, and 6 I3 is 1 ampere. 6 multiple 1 is 6 volt. So, and if you come back, okay, right now we found all of them together, but if we want to check that KVL and KCL are true, let's write this again one more time. The KCL in point A, it will equal to I1 plus I2 plus I3. Let's check. Yes. So what was I1? I1 is 3 ampere. I1 was 3 ampere. What is I2? I2 is 2 ampere. And I3 is 1 ampere. As you see, this is completely true. And what about the KVL? You said 3 equals to 3 volt equals to V1 plus V2. Okay. What was V1? V1 was 24 volts. And V2 was 6 volts. Is the same. This is 30 volt. And if you look at this, you can see that this, this resistor and this resistor on parallel. So it is very clear that V2 and V3 are equal. Okay, so it is so clear as you see V2 and V3, both of them are 6 volt. So all of them are true. So thank you so much for watching me.